This is the video introduction to Activity 2.4, Linear Expressions and Equations. In this activity, we'll analyze sequences of black and red tiles, find representations of general figures, answer algebraic questions about the tile sequences, and graph input-output pairs. We'll also learn to use function notation to express input and output relationships. We'll use our black and red algebra piece set. Let's start with functions and function notation. A function is a rule, frequently an equation, that for each input gives a unique output. The equations describing the tile sequences we have been working with can be thought of having an input, a figure number, and an output, the net value of the figure. Since the total number of tiles and the corresponding net value in a given figure does not change, then for each input there is a unique output. We can think of our tile figure sequences as visual representations of a function relationship. The function input and output relationship is usually denoted symbolically in a form such as t of n equals an expression involving n. Notice that we say of n for those parentheses. In this example, t is the function name, n is the input or the independent variable, and the value t for a specific n is the output or the dependent variable, since t depends on n. Functions are not all named t. Functions can be named using any letter or names such as chairs, t's, black-red chairs, or letters such as c, r, or w intended to denote names or other identifying features. The symbolic presentation of a function relationship is a convenient shorthand notation that allows us to write in a few symbols the meaning of an entire sentence. The function notation shorthand for describing the fifth chair figure has a net value of 9 is c of 5 equals 9. And for the nth chair figure is the figure number plus 4 is c of n equals n plus 4. Note in these examples, chair was named by the function named c. How do we use black and red tiles in tile sequences? A sequence of tile figures may use both black and red tiles. In sequences of tile figures where we use both black and red tiles, we are looking at the pattern and we are not concerned about reducing the figures to minimal collections of black and red tiles. When making counts on red tiles, it will be natural to mark them with negative integers. And when describing both red and black tile portions of the tile figures in words, it may be helpful to use words red and black. For example, you might say the figure number in red or the figure number in black. When you add to a figure number in red, note that you are adding a negative number. For example, the figure number in red plus 1 red tile converts to the symbols negative n minus 1. On the other hand, the figure number plus 1 in black corresponds to the symbols n plus 1. Let's look at a black and red tile sequence example. This example shows using the three-step pattern analysis to analyze this sequence of black and red tile figures. In this sequence of tile figures, we're looking at the pattern and we're not concerned about reducing the figures to a minimal collection. The net value of each figure is also listed in the function notation row. So here's our picture, and you can see that the red tiles grow by 1 each figure, and the black tiles grow by 1 on each figure. In words, we can describe this as the figure number in red plus 1 red tile and the figure number in black. Then symbolically, we can describe this as t of n equals negative n minus 1 plus n. Of course, that reduces to negative 1, But if we represented this tile sequence with just one red tile, we wouldn't be capturing the pattern. Now let's talk about the total number of black and red tiles. When we use both black and red tiles, we must think about the total number of tiles in some cases. For example, to answer the question, which T of n figure, and that's the previous example, has 59 total tiles, it would not be useful to simply set T of n equals to 59. Notice that T of n, which is negative n minus 1 plus n equal to 59, is unsolvable as negative 1 is not equal to 59. Instead, for this question, we must describe our T of n figure differently. Looking at our words, we see that we have n plus 1 red tiles and n black tiles. This tells us that we have a total of 2n plus 1 tiles. Then we can solve 2n plus 1 equals 59, 2n equals 58, and n equals 29. And we can conclude that figure 29 will have 59 tiles. When we check this, we note that figure 29 has 30 red tiles, that's 29 plus 1, followed by 29 black tiles, so that's a total of 59 black and red tiles. You'll get more practice with this as you work on activity 2.4.